Hello everyone. Here in this video, we are solving a problem from viscosity and it has a concept of terminal velocity. So first let me read out the problem, then I will explain you what is terminal velocity. If you want a detailed derivation, you can just go for the previous video of this playlist. Yeah, let me read out the problem for you. There are two water drops, each of mass 8 grams and 64 grams. So mass of the drops is given for you, are falling to air. They are going through air. If the first drop has a terminal velocity of 10 meter per second, what will be the terminal velocity of the other drop? That's the question. So, what is terminal velocity? As I said earlier, when any kind of a drop is falling through air, it acquires opposition to its motion because of viscous forces. So there is a law called Stokes' law, because of which there is a viscous force it experiences 6 pi eta RV, as I explained. So as the downward force weight is fixed and the upward force is increasing, that's viscous force. After some time, the drop acquires a constant velocity. That constant velocity is terminal velocity. And I have derived an expression for that in the previous video. What is the terminal velocity derivation is? To tell you, 2 by 9 r square, density of that body minus density of the fluid, that is air, into acceleration due to gravity by eta. That's the coefficient of viscosity of that air, that fluid. So if you notice carefully in this, 2 by 9 is constant, density of the body is constant, density of the fluid is constant, acceleration due to gravity is constant, and coefficient of viscosity is constant. And the only variable is radius of that drop body falling through the viscous medium. So from this, what we can write? Terminal velocity is directly proportional to square of radius of that drop. But that radius is not given for you in the problem, rather mass is given for you. So I need to convert this radius into mass. Basing on what? Volume of that spherical drop, assuming these drops are spherical, is 4 by 3 pi r cube. Density of the drop is mass by volume, and hence mass is density into volume, that is density into 4 by 3 pi r cube. That's mass. Again, density constant, 4 by 3 constant, pi constant. So mass is directly proportional to the cube of that radius. So radius is directly proportional to mass power of 1 by 3. I need r square. So r square is directly proportional to mass power of 2 by 3. So I can rewrite this equation now as terminal velocity directly proportional to r square. Instead of r square, I can write mass power of 2 by 3. That's the expression that I want now. Now what we can say further? Terminal velocity 1 by terminal velocity 2 is as directly proportional mass 1 by mass 2 whole power of 2 by 3. In our problem, mass 1 is given as 8 milligram, mass 2 is given as 64 milligram, power of 2 by 3. 8 8 is 64. So if you simplify this, what happens? That is 1 by 8 power of 2 by 3. That is 1 by 8 can be written like 2 cube, power of 2 by 3. So that is 1 by 2, cube and cube will cancel, whole square. That's 1 by 4. So V1 by V2 is 1 by 4, and hence V2 is 4 times of V1. So if you look at the problem, see what's given. If V1 is 10 meter per second, what is V2 is the question. So V2 is 4 times of V1, that is 10. That is 40 meter per second. That's how we have to solve the problem. And for all this, the central concept is terminal velocity. That's a constant velocity acquired by a body when it is passing through a viscous medium, and that is directly proportional to the square of radius of that body, which is in spherical shape. That's it. Thank you for watching.